In this next example, we're going to look at quadratic functions and how to identify the max, the mins, the zeros, solutions, y-intercepts, x-intercepts, vertex, and axis of symmetry. So here's our example we're going to look at. It is negative 2x squared plus 2x plus 12. We're going to start by making a table, sketch it, and then talk about the key characteristics. So what I would suggest doing first is you pull out your calculator and we will type this equation into our y equals. So we'll go ahead to the y equals first. And we type it in as negative 2x squared plus 2x plus 12. Okay. Now you'll notice that there's a table that we're supposed to fill out right here from negative 3 to 3. So if I go to my table setup, which is second window, I can start my table at negative 3 and have it go up by 1. Okay. Now I'm going to look at my table and I'm going to just copy those values from my table on my table on my sheet of paper here. So at negative 3, I have a value of negative 12. At negative 2, the y value is 0. Negative 1, we have a value of 8. 0, it's 12. 1, we get 12. And then at 2, we get 8. And 3, we get 0. Okay, so now we're going to use those values to help us plot some of the points on our grid. Okay, let's plot a couple of these points by hand first, and then we will look at this on the calculator as well. So the first thing we need to do is we need to realize, where we're going to be applying these points. So we have negative 2, 0. That's in our x direction. So assuming we're starting right here, we go x would be to the left 2. So we go 2 to the left, up 0. So it would be right at that location. And then we would go 0, 12. So we would count up 12 from the y-axis. So go 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. That would be right up here. And then we have 1, 12, which is right here. 3, 0. And then if we want to plot the negative 1, 8, we go 1, 2, 3, 4, 5, 6, 7, 8 would be right there. So my guess is that it's going to go through these points. But now let's look at the calculator and see what it looks like. If I just hit graph, I may or may not see the graph. Now, for some of you, you might not see it, but if you don't see it right away, hit zoom and go to zoom standard, which is number 6. Zoom standard. Now that's a little bit maybe not big enough for my window. I need to increase my Y max. So I go to my window and I change my Y max to be like 15. Now I look at the graph. I changed the wrong one. I changed the X max. I want to change my Y max. So I go down to my Y max and I change that to 15 and I graph that again. There we go. So now we see the whole graph. So we did get the correct idea from the table. So now we just kind of sketch the graph of the quadratic that we have. And then now we're going to talk about what these points mean. Okay. And it's hard to do it freehand here, but that's the idea. And what we're going to do then is we're going to start talking about the max. Let's start with the max first. Well, the max is going to be located on the top, right up here. And that's technically called the vertex. So this is our vertex of the graph. It's also the maximum value. The y value would be the max. So to compute my vertex, I go back to the calculator. And there's a special way to do that. All you have to do is go second trace. So second trace, which is in the calculate, there's a maximum function, number 4. So I select that option. I have to move my cursor to the left of where the max occurs, and I hit enter. Then I move my cursor to the right, of where the max occurs, and I hit enter. Back up just slightly and hit enter, and that gets me my maximum value. So the vertex. So the vertex is going to be 0.5, comma 12.5. That's going to be right up on here. Now the key thing on this is that when you talk about the vertex, the y value is going to be the maximum. Okay, but the maximum occurs when x is 0.5. So on the bottom, I'm going to say that the maximum is going to be equal to 12.5. Then what I need to do is I need to identify, well, is there a minimum? No, it keeps going down forever. So we'd say for the minimum there would be no minimum or none. The other thing we need to identify would be the zeros. Okay, the zeros are basically when y equals 0. So when I talk about the actual zeros, what I could do is I could simply look at my table or look at the graph. So the zeros are going to be when y equals 0. So when I look at this, it's where it crosses the x-axis. So this is my x-axis right here, and that's also on my table. It's when y equals 0. So that's when x equals -2 and 3. Those are my zeros for the function. The next thing they want are the solutions. Well, the solutions to an equation is basically it's the values of x that would make y equal 0. So it is the same thing as the zeros themselves. So when I say what are the solutions to this equation, the solutions are basically when y equals 0, and that would be at x equals -2 and 3. They may also consider these, they might call these the roots. Roots, solutions, zeros, those are all the same thing. Now there's one more term that we could say that would be equal to. And it's either going to be our x or our y-intercepts. Well, it's on the x-axis, so it's the same as the x-intercept. So when we talk about the x-intercepts, that's exactly the same thing as well. X-intercepts would be -2 and 3 as well. Then I have my y-intercept. Okay, my y-intercept is when it crosses the y-axis. So that would be when x is 0, which is right here. On my table, I can clearly see that the y-intercept would be at 12. So when I list my y-intercept, I would just say that the y-intercept is going to be 0, 12. So that's where it crosses the y-axis at. And then axis of symmetry is the line that goes right through the vertex. So it divides the parabola into 2 equal parts. And what we'd see is that, if our vertex is 1/2, 12.5, the actual axis of symmetry line would just be x equals 1/2. You have to have it as an equation, but it would be a line that would go as a vertical line that goes through the vertex. Remember, the vertex was 1/2, 12.5. So there's our parabola. Remember, because the number in the front was negative, it's going down. And because it's a -2, it's a little steeper than it normally would be if it was just a -1. It actually goes down 2 over 1 to get to the first point from the vertex that we see.